In this video, we are going to solve a problem that involves a quadratic equation in factored form. So I'll read the problem and then we'll work our way through it. I launched a rocket from the roof of my house. Its height in feet, x seconds after takeoff, is modeled by the equation below. H of x is equal to negative x plus 1 times x subtract 13. What was its height at takeoff and what was its maximum height? So a couple things before we dig into this. This is function notation. We've seen it before. It's equivalent to saying or writing y is equal to negative x plus 1 times x subtract 13. This is function notation. It just illustrates that we are substituting in a value for x and that the output, or h in this case, is dependent on the value for x. H depends on x. It's the same idea here. Y depends on the value that we substitute for x. It's just a different notation. The next thing that I want to point out here is that we have our x variable, that is seconds. X is seconds, and then using our this y variable here, we'll say that y is the height. Y is the height, again in feet. And so there are two questions that we want to answer here. The first question is, what was the height of the rocket at takeoff? And then also, what was its maximum height? So remember that the height of the rocket is just our y coordinate. The height of the rocket is our y coordinate. And so let's just say if there were a point here at 10 seconds and 50 feet, that would mean that 10 seconds after launch, the rocket was 50 feet in the air. But we actually need to figure out what this equation describes before we can make a conclusion like that. So when did takeoff occur? What was the value of x at takeoff? Well, the value for x at takeoff was 0, because 0 seconds is when the rocket launch began. And so we can write that takeoff corresponds to x being equal to 0, because that's the point at which the rocket launch started. That's when x was equal to 0. So we know that takeoff is when x is equal to 0. And so in order to find out the height at takeoff, we just need to find out what is the y value, or what is the height of the rocket when x is equal to 0. And so in order to do that, we can use this function notation here, substitute in 0 for x, and see what we get out of the function. And so I'll go ahead and do that here. So we have h, and then I'll leave a space here to substitute in x. Let's see, negative. Actually, let me just go ahead and jump in and start substituting these in. So h of 0 is equal to negative 0 plus 1 times 0 subtract 13. 0 subtract 13. So I've just taken my function here and just replaced 0 wherever I had an x. And so now I can simplify this and say that h of 0, 0 is equal to negative 0 plus 1 is the same as negative 1. And then we'll leave this here in parentheses. 0 subtract 13 is negative 13. And then to multiply those out, I have h of 0, man, can't get this right, there we go. H of 0 is equal to negative 1 times negative 13, which is positive 13. And so that tells me that when x is 0, y is 13, or h of 0 is 13. And so the coordinate pair that corresponds with the height of the rocket at takeoff is 0, because that's my x value, and then 13, which is my y value. So 0, 13. Those are the coordinates of the rocket at takeoff, and so I will mark that point on my graph here. So we have my x value, or my x coordinate is 0, my y coordinate is 13, so it puts it right about there. And so that is those are the coordinates of the rocket at takeoff. So remember, 0 seconds after launch, so in other words, right when takeoff happened, the height of the rocket was 13 feet. And remember, that's because I launched it from the roof of my house. And so you could conclude here that the roof of my house is 13 feet off the ground. Okay, so we've found the height of the rocket at takeoff. Let me just make a note of that here so we don't forget. It's 13 feet. And now we want to find out what's the maximum height that the rocket reached. The maximum height. So you can imagine that the rocket followed some sort of path. I'll just do it in dashes here. Followed some sort of path. And note that this is not the path through space. This is if we measured the height of the rocket at 0 seconds after launch, 5 seconds after launch, 10 seconds after launch, so on and so forth. We want to find out what was the height that the rocket reached. And the maximum height is going to be at the vertex of the parabola, so the highest point of the parabola. So let me just erase those, and then we will figure this out. Okay, so for the maximum height, like I said, the maximum height is going to be at the vertex. So let me write that out. So max height is at the vertex. And so all we need to do is we need to find the vertex of this parabola. And so when we find the vertex, what we want to do to start is we want to find out the x-intercept, so where the graph or where the parabola crosses the x-axis. And then the vertex is going to be halfway in between those two x-intercepts, or I should say the x-coordinate of the vertex is going to be halfway in between those two x-intercepts. So we have x-intercepts at 2 points. So x-intercepts at, now looking at the function here, we have one x-intercept when x is equal to -1, and I can see that here because if I substituted in -1 for x, then I would have -1 plus 1, and that would make this set of parentheses equal to 0. And so that would multiply to make the entire right-hand side of the equation equal to 0. So I must have one x-intercept at the point -1, 0. And 0 is just my y-coordinate. That's, remember, our y-coordinate is 0 whenever we're right on the x-axis. And then here, I can tell that I have another x-intercept at +13, because if I substituted in +13 for x, then I would have 13 minus 13, which is equal to 0. And so this set of parentheses would be equal to 0. That would multiply to make the entire right-hand side equal to 0. And so I have another x-intercept at 13, 0. 13, 0. So these are my two x-intercepts. Those are the points on the graph where where the parabola crosses the x-axis. And so I will mark those here. So we have one at -1, which is about right there, and then another one at +13, which is about right there. So I have my y-intercept, I have my x-intercepts. Now I just need to find out where my vertex is in order to finish graphing this and to find out what the maximum height that the rocket reached was. So remember, my axis of symmetry, the x-coordinate of my axis of, or I should say my axis of symmetry will be halfway in between these 2 points. And that's the nice thing about parabolas, is that they're always symmetric. So I know if I have an x-intercept here and an x-intercept here, then my axis of symmetry will be halfway in between. And so what is halfway between -1 and 13? Well, I can work that out here. I can just take the average or the arithmetic mean of -1 and 13. So that's -1 plus 13, which is equal to 12. And then I just divide that by 2 because I have two numbers. This is just taking the arithmetic mean like we did back in unit 1 or 2, I believe. So 12 divided by 2 is 6. And so that tells me that the x-intercept, or sorry, the x-coordinate of my axis of symmetry is 6. And so I'll mark that on the graph here. My axis of symmetry is going to be at 6, which is going to be right about here. So this is the axis of symmetry. This is the line at which both sides of the parabola will be mirror images of one another. And so the vertex is going to sit on the axis of symmetry. So I know that the x-coordinate of my vertex is 6. because 6 is the line, x is equal to 6 is the line that defines the axis of symmetry. So if I know that the x coordinate of my vertex is 6, that it's at x is equal to 6, then I can just substitute 6 into my equation here and then find out what I get as my output. So I'll rewrite that here. So I have h of 6, I'll use that same yellow color, h of 6 is equal to negative, and then 6 plus 1, 6 plus 1, and then again 6 subtract 13. So I can just simplify here. So we have h of 6 is equal to, let's see, negative 6 plus 1 is 7. So negative 7 times 6 subtract 13 is negative 7. So times negative 7. And negative 7 times negative 7 is equal to 49. And so we know that our x-coordinate is 6, our y-coordinate is 49, and so the point of our vertex is at 6, 49. And so we can graph that on our axis of symmetry here. So I go over 6, that's my x-coordinate, and then up 49, that's my y-coordinate, which is right there. And so I have all the points I need to define this parabola, and I will do my best to sketch it here. I'm going to go down through my y-intercept and then one of my x-intercepts. A little crooked, that's okay. And then down here through my other x-intercept. And so that is, that's a little crooked, that is an approximation, I should say, of the parabola defined by this equation here. And these are the important points. This was liftoff at 0 seconds and 13 feet above the ground. This is our maximum height right here. Our maximum height at our vertex. And I'll label that up here. Our maximum height was at 49 feet. And then what would this point define? What would this point be right here? Well, this is the point at which the rocket hit the ground, because this is 0 feet above the ground, in other words, the ground, and it would happen at 13 seconds. And so there would be 13 seconds of flight time, and then it would crash or land or whatever at 13 seconds. So we've answered the two questions that we were asked. So what was its height? At takeoff, its height was 13 feet, and what was its maximum height? Its maximum height was at the vertex, which was at 49 feet.